Hey everyone, how are you guys doing? It's a Sunday morning. I'm just relaxing myself after waking up. Um, just been doing typical stuff anyone would do on a Sunday, chilling out, having a cup of coffee, and enjoying the morning sun, looking through the windows. And I hope you're all doing great. And now, today, I just want to talk about the acid properties. Like, I've been trying to get to this, but I've been going around other topics like what are the different types of database and flat files, difference between flat file and the database, and all sorts of other things than this. But this is a very important concept, and you need to grab onto this concept if you would like to really do an acid test, literally an acid test, as to determine if a database is really a database that's capable of handling a large amount of data and do the transactions well without showing much of faults or inconsistencies, and can it really handle the workload? Is it really a good RDBMS or not? How do you know? So you do an acid test. So ACID is an abbreviation that stands for these things. ACID stands for atomicity. If ACID is an abbreviation that stands for stands for atomicity, C stands for consistency, uh, I stands for isolation, and D stands for durability. So if you want to call an RDBMS or a database a really good database, it should be capable of having meeting all these properties. It should pass this acid test, so to speak. So let's start with atomicity. So what is meant by atomicity? So what do you like to think uh, when you hear this word atomicity? So there's atom in it. So what is atom? Atom is the smallest unit. So if you take any kind of a matter in physics, you break down that matter uh, breaks down into what you call as the molecules. If you just keep breaking them down, um, the minutest thing you could find is the molecule. They call it molecule. And if you break it even further, the molecules will get broken down into atoms. And of course, within the atoms, you have all those protons, neutrons, and electrons. So I don't want to get anything beyond the atom. But if you simply talk about atom from the physics point of view, atom is nothing but the smallest unit of a matter, right? So atom is the smallest unit of the matter. In the same way, transaction or the atomicity is nothing but um, a property in which there is a smallest unit. They are talking about a smallest unit, and the smallest unit is called as a transaction. In database perspective, the smallest unit is transaction. In the physics perspective, the smallest unit is the atom. All right. So, so what is this transaction? What am I talking about? So let me give you an example of what a transaction is. The typical example anyone would anyone would portray when it comes to demonstrating what a transaction is a banking transaction. So let's say you walk into a bank ATM, you withdraw some cash, okay, um, $100 or whatever currency, 100 rupees, or 100 yuan, whatever the currency your bank is tied to. So you're withdrawing some cash from the bank, and let's say you take out $100 from your account. So what happens? Um, as soon as you take the $100 out of your account. So what happens is your transaction uh, succeeds because you have taken out $100, and then your balance is reduced, right? Your balance is no more. Let's say you had $10,000 in your account, and as soon as you have taken out the money, $100, you have $9,900 left as a balance. So why am I quoting this example? So what you've done is a transaction. It's in front of you, it's a banking transaction, but behind the scenes it's actually a database transaction. Somewhere there is a banking database out there, and that is all been abstracted, that's all been hidden from you, because you're just a banking user, you're a banking customer. You don't need to know which database is getting updated. So those are all due to security aspects or whatever that's been kept away from you, and you don't have to know. See, there's a car, and there are a lot of parts underneath the car. Okay, there's an engine, four-stroke engine that's there, and there's a radiator, there's a coolant, there's a water pump, and there are so many other parts, moving parts, and probably there's also a automatic transmission, and everything is working, but the car just simply runs. You're just driving the car. You don't have to actually know what's going on behind the scenes. You don't need to see what's under the hood. It just works. Same way, um, the banking transactions, they're just simply there. You just pick the money out, see the balance, you got the money, and you're good. So as far as the database is concerned, what you've done is a transaction, and and that's like $100 transaction. You have taken out $100, and it's the transaction is done. So the atomicity is a rule that ensures that the database, either the database, the date, I mean, the transaction is either committed in the database or it is rolled back. There's no in between state where it's like, I'm going to be doing or not going to be doing the transaction. Database has to take a decision, and it has to um, succeed that transaction, what the customer is doing. Let's assume database is the person who is behind the scenes, and he's telling you, hey man, I'm going to give you the $100, I'm going to make this transaction successful. However, if something happens in between, let's say something happens with the network during the particular day, there's a power outage at a major place, like a hub where the power is distributed to various other uh, data centers, or you know the power in the ATM just goes away while you're doing the transaction. Let's say the ATM broke, there's something wrong with the ATM machine, and the power goes off. So you have touched the button to withdraw cash, and the power goes off. Okay, this is the scenario that I'm asking you to imagine. So what happens there is your transaction has to be aborted by the database. The database behind thinks, oh, what happened here? I'm trying to give the money out, but the money is not getting out, and the user has not received, the customer has not received that money which I asked him to withdraw, like which he has requested, but it's not been received yet. What the hell is going on? I don't know. So the database then decides, uh, okay, this guy is not able to withdraw cash. So what do we do here? Let's roll back his transaction. So by rolling back, the database is essentially doing is it's failing the transaction for the customer's good, because well, let's say the cash has been shelled out, but the machine doesn't work. Okay, and the transaction has been executed. It's a kind of a tricky situation, right? Like the customer has not received the cash, and the where did it go then? And the balance has been deducted. What the hell? You can't allow that. So, uh, succinctly speaking, a transaction is nothing but a unit of work. So it's just a unit. It's a just like how a unit of energy is joule. They say a unit of energy is joule in physics. So this is a unit of work, that is joule. Whatever the work that's being performed. So I'm sorry to talk about physics, but it's just an analogy. I'm trying to say this transaction is nothing but a unit of work when it comes to a database. So it's also one of the fundamental units of uh, database. But here we are talking about the database work. So all the work for the database is carried out through the transactions. All right. So that's why they call it a unit of work transaction. So transaction in when it comes to atomicity property, the transaction has to either commit or it has to roll back. There are only two states when it comes to a transaction. You're doing a transaction, the transaction has to either commit to the database and the balance has to be updated, right? Or it has to roll back the transaction because of whatever issues like the network issue or the power outage, whatever may be the reason. The transaction should either be committed or it should be rolled back. The rollback is the failure of the transaction. Okay, this didn't go through, so give him a receipt. Give him a receipt like the transaction has been cancelled. Uh, when you receive the transaction has been cancelled, you check the balance again when the power comes back, and you see it's the same. $10,000 still remains in your account. Nothing has happened. So this is a pretty important thing you have to know. So this is the first of the four properties, atomicity. It's nothing but talks about the transaction which should either commit or roll back. So I'm telling this again and again because this has to get into our subconscious. Like next time when we talk about database, hey, what are you talking about? You're talking about atomicity? Oh, atomicity. That's the transaction. The transaction should either commit or roll back. Is that what you're talking about, bro? Yeah, I'm talking about that definitely. Yeah. Okay. Cool, man. You know the stuff. All right, then we are going to next deal with the second property. That's atomicity. T stands for what? Uh, yeah. Oh, sorry. I'm sorry. Acid properties. A stands for atomicity. C stands for consistency. All right. So when you're talking about consistency, you're talking about the constraints in the database. There are like so many business rules in the database you have. Like for example, let's say you have a primary key in the table. So the primary key is one of the things in a table. Um, it's kind of a business rule that's kept in order to make sure that each and every transaction is unique. Like if you're talking about a table, then a table can have one primary key. And let's take the case of an employee table. Okay, in a company, an employee, whenever he gets recruited, like as soon as a candidate gets recruited for the company, he gets added into the employee database and he will get an ID card. When you join a company, you get an ID card, don't you? So the ID card, uh, with the ID card, you get what is called as an employee ID number, right? You would have seen that in the employee ID card. So the primary key is one of the things that makes sure that each and every employee ID is unique, right? Like if I'm one of the employees in the company and I have a unique ID that's not the same ID as someone else who's going to join tomorrow. or who has already joined yesterday. So their ID will be different. So the job of this primary key is to ensure there's uniqueness. So this is just a one small example. When you talk about the transactions, you take a transaction called T1. Okay, someone like me is doing a transaction, the bank ATM, and there's another person somewhere in the other street in a different branch. He is also doing a transaction called T2. All right, and let's say he's my brother. Okay, and we hold a joint account. All right, uh, so he's also withdrawing cash from the same account. Like I'm also withdrawing cash. Let's say I'm depositing cash. All right, so let's say I deposit the cash first in the ATM, and while I'm doing the deposit, he's withdrawing cash at the same time. All right. So before my deposit goes through, I check the balance the first time, and the balance shows $10,000. And then he gets to withdraw $100 out there somewhere. And while I deposited $100, what's going on? And I look at the balance after depositing the $100, and it still says $10,000. What the heck? And my brother over there on the other side of the street, he has withdrawn, and I'm not aware of that. So if I take a mini statement or something, and that tells me right before I deposited, there was another transaction that went through that was from my brother and who withdrew some cash of $100. And that tells me, okay, my brother has withdrawn some cash somewhere at the same time while I was depositing. That's why the transactions, um, that's why it did not reflect in the balance. And I'm happy about that. So that's called a consistency. And if I go, this is just one of the other examples. To be more relevant, what I'm trying to tell you here is like every time you do a database transaction, it should give a consistent result. The balance should reflect exactly what I intended to do. Like if my brother has withdrawn cash in this instance, um, so the balance looks good. Okay, that's acceptable. So let's say my brother did not withdraw cash, like he was on his way while withdrawing, but he did not commit the transaction fully. Like he was he tried to get the cash, but for some reason ATM machine did not work or whatever, and that $100 still gets deducted from my account. That's brutally bad for a customer, for a business account like what we have between me and my brother, because that's going to deduct $100 from my account, and what am I going to do? So that's really bad. uh, what essentially has to be there is the database has to be consistent. It has to be following all those business rules, such as the primary key, for example, is one of the rules. And there are also other business rules like the foreign key. For instance, uh, in certain scenarios, you have what is called as a foreign key. A foreign key is like a relationship between a parent and a child table, and whenever you update something or delete some record in the parent table, somehow it will reflect something else based on whatever kind of a rule you set. Like on update, it the child table also needs to be updated, and you cannot update a child table without updating the parent table, and you will come to understand all of those. So essentially, the consistency is nothing but the maintaining uh, the business rules in the database. That's what consistency is all about. All right. So we have got just a couple of more properties to deal with: the isolation and durability. Let's talk about isolation. So I'll take the same example of me and my brother doing the transaction. So both those transactions are isolated from each other. That is a different transaction. And what I'm doing is a different transaction. So let's take another case. You're doing an airline booking, okay? There are only limited number of seats in an airline, okay? Let's say 100 seats are there. And I'm one of the, so let's say the slots got open. There's so much of demand and for the next month's flight, and there are a lot of people competing to get a ticket in the plane. Okay, let's assume it's the Air India for the sake of simplicity, and there are hundreds and thousands of users trying. So not just the thousand users, all thousand users will be able to get uh, a ticket booked. There's only 100 people who'll be able to get the tickets booked. All right. And let's say, for the sake of simplicity of this example, we're only booking economic class, and business class and other classes have already been booked, or the price is too high, and these thousand people, they don't bother about that. Okay, for whatever reason. So in the economy class you have 100 seats, and thousands of people are trying at the same time. So can all the 1,000 people be able to book? No, as I told you. But there's 100 people among them in the lottery where database will be able to book the seats for them. All right. So let's say this, uh, among the 100 people, all these 1,000 people who are trying to talk through the application and talk to the database, they're trying to do the transactions. Each of them is doing a transaction. So the isolation is nothing but treating all these transactions as a different transaction, like a unique transactions. They shouldn't interfere with other transactions. Let's say if I am doing a booking, um, I mean, they have to maintain concurrency, so to speak. So they're isolated at the same time, they're also concurrent. Okay. Um, so let's, all these 1,000 people, they can't all be doing it at the same time, exactly at 9 o'clock and 9 seconds, nothing like that. So I may be doing 9 o'clock and 5 seconds. After that, somebody will be doing at 9:05, somebody will be doing at 8:59, or maybe 9:02, or 9 o'clock and 5 minutes past 9 o'clock. So there are different times. So every time you talk to the database, a unique transactions running behind the scenes, behind the curtain, and that transaction has to be isolated from the rest of the other transaction. Because what happens is, let's say my transaction is going and I have entered my details, like my name, my passport number, and all those details, my work authorization and other things. um, and there's somebody else who who's booking the plane, and his name is different, his ID is different, his passport number, everything is different. So if I get a transaction saying somebody else's name has been booked, and his um, for whatever details I entered, if I get the result of the other person, it would really be very confusing to me. What the hell? I entered my details. Why somebody else is getting booked for that? And what happened to my details? Where did it go? So it's a problem, right? So it shouldn't be like that. So isolation is another property where each transaction has to be isolated from rest of the others, so that the transaction uh, executes, and at the same time it enables concurrency. Concurrency is nothing but a feature where the database lets every user, it gives an equal opportunity for everyone, almost an equal opportunity. So there is always a sliding bar, like there is a most concurrent database, there's a least concurrent database. It's just you know there's a trade-off between concurrency and serialization. Yeah, serialization is just another term that's opposite of concurrency. Um, but what I'm trying to say is, the more the number of users who's trying to compete, the database is trying the best to give equal time to appear as being concurrent to everyone. Like, okay, everyone is given an equal opportunity, irrespective of whatever status they are, and irrespective of race, gender, ethnicity, or anything. Um, so the database is just for the database. These are all just users who are trying to compete for resource, the database resources. Which in this case is just a ticket, a flight ticket, and a seat. Okay. Well, so everybody concurrently tries to get hold of a seat. This is what is concurrency. So among the 1,000 people, the first 100 people, whoever got hold of the seats and were able to talk to the database, they got it booked and their transaction went through. And for the rest 900 people who tried at the same concurrent time between 9 o'clock and let's say up to the 10 o'clock window, and the 900 rest of the 900 people, they weren't able to book the tickets, and the transaction came to them like the transaction didn't go through. All right. So this is what the consistency is all about. uh, that's just sorry This is what the isolation is all about. The concurrency, isolation, they're all like tied with each other. And of course the consistency is also tied to each other. Atomicity is also tied. These are all like, if you go through an example, and what I suggest you to do is just take a scenario, just take a banking example or a flight booking, or take an employee database in a company, and just think through, like, okay, this is the business, what is the business doing, and what sort of things they have to ensure to be able to meet all these requirements of atomicity, isolation, consistency, right? And think about uh, how the applications can be ensured all these properties when you want to design a database. Like, just in a very simple way, you just think, okay, this is the database, I'm designing an employee database. What should the atomicity be like in an employee database? Well, an employee gets added, that's a transaction. An employee tries to read from the database what is his employee number, or a manager tries to read, and that's a transaction, that's a read transaction. There's a data entry operator over there who is updating a new record for a new candidate who has joined our company as an employee. And if the transaction goes through, and the employee number gets generated, and if it's a unique number, okay, there you go. It's very consistent. However, if the transaction is going through and for some reason it's trying to enter a duplicate entry, the same employee number like the other employee who joined yesterday, that's something that shouldn't go through. That's an example of inconsistent database. It's, that's not a database. So you can't be a database anymore, because you are if you're behaving inconsistently, that the duplicate employee number should not be added. So how do you ensure um, duplicate row is not added? So that's the job of the database. The database has to do that. But what you will have to do as a database admin, you have to create a primary key, and that's all. If you have created a primary key, there's no way to ensure the previous record in the table that got added for the other employee doesn't uh, get generated as an employee ID for the new employee you're adding today. Okay, so that's the that's how you have to think. Like I've just given you an example. And the last property we're going to talk about is the durability. What is a durability in general? What do you mean by durability? You take a weapon, for example, a sword. Okay, so the longer a warrior starts using and swinging the sword, right, using it in the battles, the durability goes down. The durability is like it starts to get weakened, and let's say it's just go and look up durability. What does it mean? Let me do a very simple task of getting to the Google and looking up for the word durability. So durability, it says, is the ability to withstand wear, pressure, or damage. That's exactly what it is talking about. So what happens when somebody swings the sword and uses it in the battle, and then over a period of time the sword gets damaged due to the wear and tear. Okay, or let's take the tires of the car. The tires of the car, as it gets older, it starts to deteriorate, and at some point in time the tire has to be replaced. Otherwise the tire is no more, it's no good. You can't rely on the tire. It can burst at any time while you're driving, which is a very dangerous scenario. So how do you relate this term with the database? Let's take a database is running perfectly, it's running very nice, and on a fine day, uh, for some reason somebody pulled the plug in the data center, but the database goes down. What do you do to recover the database? If you have a backup, you can recover the database. So that's what durability is. You should have a backup. You should be able to restore the database at any point in time and bring it back to where to the time when it went off. Okay, that's called the durability. It's the ability to bounce back from the failure. That's what the durability is about. So these are the basic things that are needed if you want to call a database a database. Has to meet the asset properties. Otherwise, the database, it cannot be called a database. It's something you tried to create, but it didn't come out well. All right, thank you guys. I'll come up with something else next topic. Thank you very much for watching. Bye.